Okay, good morning, period one. So this is our last lesson for unit 13. I know I said day 3, but day 3 was just practice day. So we're going to go right into day 4 and last day lesson, still solving for x, still in radians, and still have the same restriction that we're between 0 and 2 pi, and we can only equal 0. So looking at this first problem, I have sine squared plus 3 sine x minus 3 equals 0. It's set up to factor, looks like we already know what we're doing. However, if we try to factor it, it's not going to factor. So just like in any other quadratic, if it does not factor, we need to use another method. So we're going to use the quadratic formula. And we're very happy about it. So in case you forgot, and I'm sure you guys would never forget, your quadratic formula is negative b plus or minus the square root, b squared minus 4ac all over 2a. Okay, remember it's going to be in the format ax squared plus bx plus c is 0. So we can pull out a, b, and c. So in this problem, a is 1, b is 3, c is negative 3. Okay, and that doesn't solve for x. This is actually going to solve for sine of x. So I'll start off saying sine of x is, so if I'm going to do negative b, negative 3, plus or minus square root, 3 squared is 9, minus 4 times 1 times negative 3 over 2 times 1. And I'm just going to work through and simplify this. So negative 3 plus or minus root, this becomes 9 plus 12 over 2. Negative 3 plus or minus root 21 over 2. Root 21 does not simplify, and I am allowed to use a calculator. So what I'm going to do, I'll actually add a page to split this up. Maybe I won't. Okay. So I'm going to say sine of x is negative 3 plus root 21 over 2. And I'm going to do a separate equation where sine of x is negative 3 minus root 21 over 2. So remember, for our domain restriction, sine has to be between negative 1 and positive 1. So the first thing I'm going to do is see if this value, negative 3 plus root 21 over 2, is in that domain. So I do negative 3 plus root 21 over 2. Okay, it's in my domain. Great. So this works. It's in the domain. And the calculator shows me that it's a positive value. So I look back. Okay, ASTC, sine is positive in quadrants 1 and 2. So in quadrant 1, I would just do inverse sine of this value. And in quadrant 2, I'll do pi minus inverse sine of that same value. And since I already evaluated on here, I can just do inverse sine of my last answer, enter. So we'll still round to 3 decimal places, 0.913 is quadrant 1. And because I'm going to use the calculator to help me, I'll store that value as x. This way, when I'm going for quadrant 2, I can just do pi minus that stored value of x and get 2.22 round up to 9. Okay, so I'm going to have to do the same thing over here. I need to first make sure that negative 3 minus root 21 over 2 is in my domain. So negative 3 minus root 21 over 2. It is not my domain. It's not between negative 1 and positive 1. That equation does not work. So I get 2 answers just from that first part. Sometimes you'll get problems where you get solutions for all 4 parts, and you'll get some where you only get it for 1 equation. And we'll kind of go through a few different problems like that. So your next one, 2 tangent squared minus tangent minus 5. I would always try to factor it first. Let's say 2 tangent 5 and 1 won't work, and 5 and 1 won't work. Okay, so it doesn't factor. But you should always try to factor first. You're still going to have problems that do factor. So it doesn't factor, go through quadratic. A is 2, B is -1, C is -5. So I'm doing negative B, so -1 is 1, plus or minus root B squared, -1 squared is 1, minus 4 times 2 times -5 over 2a, 2 times 2. So 1 plus or minus root, let's see, that's 1 plus 40 over 4. 1 plus or minus root 41 over 4. And I should have written that this is what tangent equals, because in this problem, that's what I'm solving for, tangent of x. So just like I did in the last problem, I'm going to split it up. Tangent of x is 1 plus root 41 over 4, and tangent of x is 1 minus root 41 over 4. So I don't have to check if it's in the domain. I know it is because tangent domain is full real. So no matter what, if it's a tangent problem, these are actually both going to work. 1 plus root 41 over 4, I can use what I know in math to know that's going to give me a positive answer. But if you're unsure, go into the calculator, type it in. 1 plus root 41 over 4. Okay, positive value. So I'm looking in this first equation for where is tangent positive, quadrant 1, quadrant 3. So quadrant 1, I'll do inverse tangent of this value. And quadrant 3, I'll do pi plus inverse tangent, that same value. So since I already have the value in my calculator, let's do inverse tangent of my last answer. 1.075, so that's the value for quadrant 1. And I'll do exactly what I did in the last problem. I'm going to store this as x. So this way, in quadrant 3, I can just do pi plus my stored value of x, 4.217. Okay, 4.217. Okay, and look at that second equation. Tangent of x is 1 minus root 41 over 4. Okay, so this is important. Let me just clear these out. 1 minus root 41 over 4. It does give me a negative value. So because this is a negative value, I go through and I can determine that tangent's negative in quadrant 2 and quadrant 4. I need to make this value positive before I figure out what its measure is. So all I'm going to do, I'm really taking the absolute value, but in the calculator, I'll just multiply it by -1. Oh, not twice. There we go. Okay, I need to see that positive value in order to get the right value of the angle. The negative just gives me the quadrant. But when I'm evaluating, I need it to be positive. So in quadrant 2, I'm going to do pi minus inverse tangent of the value above. And in quadrant 4, I'll do 2 pi minus that same inverse tangent of the value above. So just like I did before, I'll just do inverse tangent of the value first. And I'll store that as x. So in quadrant 2, I'm going to do pi minus that stored x value. And in quadrant 4, I'll do 2 pi minus the stored x value. So I get 2.208 and 5 point, we'll round up, 350. Okay, so quadrant 2, I'll just write these down here. Quadrant 2 ends up equaling 2.208. And then quadrant 4, we got 5.350. So in that problem, you see we got 4 answers. How to use the calculator on all of them. That's probably the most involved a problem can get. So now problem 3, sine of x, cosine of x equals 1/4. So it doesn't factor, it can't do quadratic, and we might just be thinking we can't do this, but we can do this. We just need an identity in here. Okay, so the identity that we know is sine of 2a is 2 sine A plus sine A. So I'm sure you guys have that list of identities pretty handy. And out of all 16 identities, this is the closest match. So I am missing the 2 in front. If I want that 2 in front, I can do that. I just need to, like any other equation, keep it equal and multiply the other side by 2. I'm able to do that because now this matches the right side of the formula. So I can interpret that and say that this is really sine of 2x. On the right, 1/4 times 2 is 1/2. This goes back to what we did in day 1 now. If I have an angle that's 2x, I'm going to substitute a. So I'll say a equals 2x. Sine of a is 1/2. And I know that this is going around the unit circle twice, right? Because I have that same restriction that I've had this entire unit that x is between 0 and 2 pi. So now if I multiply that by 2, I'm going to be between 0 and 4 pi. So 4 values most likely. Okay, so sine of a is 1/2. I'll sketch out a 30, 60, 90 because that will likely match one of those angles. Okay, so sine 1/2, this is a 30-degree angle, but I'm working in radians, so I make that pi/6. We're positive for sine, so we'll be in quadrant 1 and quadrant 2. So in quadrant 1, I say pi/6. In quadrant 2, I do pi minus pi/6, and I get pi/6. These are in that first rotation. Second rotation, I'm just adding 2 pi to these values. So if I add 2 pi to pi/6, I get 13 pi/6. And if I add 2 pi to 5 pi/6, I get 17 pi/6. These all equal 2x, but I want to solve for x, so I divide them all by 2. Same thing as multiplying by 1/2. So I get pi/12, 5 pi/12, 13 pi/12, 17 pi/12. These all are correct solutions. One last problem. So I have tangent of x plus 3 cotangent of x minus 4 equals 0. You definitely want to notice that you have two different trig terms here. You have tangent and you have cotangent. I need them to be the same. And we're so lucky these are actually related. So I'm going to keep tangent, tangent. In order to rewrite cotangent, I know cotangent of x is the same as 1/tangent of x from our favorite identities unit. So I can say that this is 3/tangent of x. Keep the minus 4. I definitely can't factor if there's a fraction in there. So to clear that out, I'm going to multiply every single term by tangent of x. And I know it doesn't really matter on the right because that's 0, but I'm still showing it so you can see that I'm doing it. So I get tangent squared x plus 3 minus 4 tangent x equals 0. I rewrite it, so I'm in descending order. So tangent squared x minus 4 tangent x plus 3 is 0. And this looks like it's a factor. So tangent x minus 3, tangent x minus 1, yeah, it factors. Remember, tangent domain is all real, so these should both work. Tangent of x is 3, and tangent of x is 1. All right, tangent of x is 3. That definitely does not work for 3, 60, 90, 45, 45, 90 triangle, but it's positive. So tangent is positive, 1 and 3. So quadrant 1, I'm doing inverse tangent of 3, and in quadrant 1, 2 is, and in quadrant 2, I'll do pi plus that same inverse tangent of 3 value. So go to the calculator, figure out what's inverse tangent of 3. Okay, so 1.249 is my answer for question 1. I'll store that as x. 1.249. Okay, and quadrant 3, I'm going to do pi and add on, exporting this x. 4.39, round up to 1. second equation, tangent of x is 1, that's in our domain also, and that does work. So don't just jump to the calculator, because this is actually a 45-degree angle. 1 is 1 root 2, right? Tangent of 45 is 1. Okay, so 45-degree angle, and make it radians, pi over 4. I'm still positive, I'm in the same two quadrants, 1 and 3. So in quadrant 1, pi over 4 is pi over 4. And quadrant 3, add pi to pi over 4, and I get 5 pi over 4.